Today's video is on integration using residues. In today's video, we are going to evaluate the integral using residues. Now, in this video, we are going to evaluate integral 0 to pi d theta by 1 plus a cos theta, where a lies between 0 and 1 using residue theorem. See here, first of all, we have to find out integral 0 to pi d theta by 1 plus a into cos theta. So 0 to pi means 0 to 180 degrees. So I am rating this as half times of 0 to 360 degrees, that is 2 pi into d theta by 1 plus a into cos theta. Instead of finding this value, so I am going to use this integral, that is half times of 0 to 2 pi d theta by 1 plus a cos theta, as these both values are equal. So for this, first of all, I have to put z is equal to, see here, put z is equal to e power I theta, and z is equal to, this is e power I theta is nothing but cos theta plus I sin theta. Here mod z value is equal to, here mod of cos theta plus I sin theta, so which is equal to root over cos square theta plus sin square theta, and therefore mod z value is equal to 1. So we got the region as a unit circle. So with center 0 and radius 1, we got a small circle here. And the next thing here is we want d theta. For finding d theta, as we have z is equal to, see here, z value is equal to e power I theta. If I make a derivative on both sides, dz is equal to e power I theta into I into d theta. See, so e power I theta is nothing but z. So dz is equal to zi into d theta. I need the value of d theta, as d theta value is equal to dz by zi. Clear? So even I got the value of d theta. After finding d theta, see here, I need the value of cos theta. So for cos theta, what I am going to do is, for cos theta, we have cos theta can be written as e power I theta plus e power minus I theta by 2. So here e power I theta is nothing but z. So cos theta can be written as, this is z plus z inverse by 2. So cos theta value is equal to z plus 1 by z by 2. And therefore cos theta value is equal to, cos theta is equal to, if I take z as LCM, this will be z square plus 1. Already there is 2 here. Therefore, cos theta value is equal to, this is z square plus 1 by, this is 2z. As we got cos theta value for substituting in this integral. So, all the values are ready here. D theta value is ready. Cos theta value is ready. Now, I am going to substitute in this integral. So which integral I am going to take? I am going to take this one, that is half times of. So this value is half times of 0 to 2 pi d theta by, this is 1 plus a into cos theta. Here this can be written as, half times of. So this value is half times of 0 to 2 pi. What is d theta? So d theta is nothing but dz by zi. So this value is nothing but dz by, this value is zi by 1 plus a into cos theta. What is our cos theta value? Which is equal to z square. So this is z square plus 1 by 2z. So the value here is z square plus 1 by 2z. See, this can be written as, after substituting all the values, now I am going to calculate this one. So this will be, so the value here will be half times of, so this value is equal to half times of 0 to 2 pi. This value is dz by, this value is zi into, if I take 2z, if I take 2z as LCM, this will be 2z plus a into z square plus a. Now I can cancel this z and even this 2 also. So after cancelling 2, so what remains here? Integral 0 to 2 pi, this is dz by, this value is az square plus 2z plus a. And here I remind here. So now see here, so this is integral f of z into dz. So what is our f of z value? So f of z value is nothing but, so f of z from this question is nothing but 1 by I times of, this is a z square plus 2z plus a. Now, in order to find the poles, we have to equate this denominator to 0. So, if I equate this denominator to 0, this will be I times of, this is a z square plus 2z plus a is equal to 0. So, this will be a z square plus 2z plus a is equal to c. I am going to apply one formula, that is minus b plus or minus. See here, as everybody knows here, this is minus b plus or minus root over b square minus 4ac by 2a. So if I apply this formula, this will be minus b. So this is minus 2 plus or minus root over b square minus 4 into a into c. So this is a square by 2 into a value is 2 here. This is minus 2 plus or minus. If I take 4 from the root, it will be 2. This is 1 minus a square by 2 into a. So if I take 2 common, this will be minus 1 plus or minus root over 1 minus a square by 2 into a. So if I cancel this one, so this will be minus 1 plus or minus root over 1 minus a square by a. So let us suppose that alpha and beta are the two roots. So two poles. Let alpha comma beta be the two poles of the function, be the two poles of the given function. Therefore alpha value is, so alpha value is equal to minus 1 plus or minus, so the roots of alpha comma beta are minus 1 plus or minus root over 1 minus a square by a. Now alpha is equal to, now alpha value is equal to, so alpha value is equal to minus 1 plus root over 1 minus a square by a, and beta value is equal to minus 1 minus root over 1 minus a square by a. Clear? And therefore we have to see which pole is inside or on or outside the pole. So here given that mod z value is equal to 1. So I'll show you this one. Mod z value is equal to 1. So clearly the region here is mod z is equal to 1. And therefore what is mod z is equal to 1? So mod z value is equal to 1 means, so this is a circle with center 0 and radius 1. So this will be I and this is minus I. And let us check this one. This is already minus 1. So this is, if I take 1 as greater than 0, so this value is greater than 0. So this is 0 less than a less than 1. So this value is in between 0 and 1. So if I take 0.9 something, so this will be minus 1 and something which is very greater than 1. Therefore beta lies outside the circle. So beta lies outside the circle, and here if you see this is minus 1 plus, so the value minus 1 and plus 1, again subtraction, so alpha will be inside this circle. So we have to find the residue for this pole. Before finding the residue, so I'll modify this the function. So the function value f of z value is equal to, so what is our f of z value? Just now I have shown, this is I times of, see this is 1 by I times of, this value is az square plus 2z plus a. So this value is az square plus 2z plus a. So in this, if I take a common, so f of z is equal to, see clearly, f of z value is equal to, if I take a common from this, this will be z square plus 2 by a into z plus a by a. Clear? And therefore f of z is equal to, so f of z value is equal to 1 by, this is ai, this is z square minus of minus 2 by a into z plus 1. Clear? And now see here, so we have two values ready, that is alpha and beta. So alpha value is nothing but, see alpha value is nothing but minus 1 by a plus root over 1 minus a square by a. And here beta value is minus 1 by a minus root over 1 minus a square by a. So sum of the roots, So alpha plus beta, if I do, minus 1 by a plus root over 1 minus a square by a, and this is minus 1 by a minus root over 1 minus a square by a. So if I subtract these two, the answer will be minus 2 by a. So we got alpha plus beta as minus 2 by a. Clear? So we have to keep it in a mind that alpha plus beta value is nothing but minus 2 by a. So let us find out the product alpha into beta. So what is alpha? So alpha is nothing but minus 1 by a plus root over 1 minus a square by a, and beta value is minus 1 by a minus root over 1 minus a square by a. So a plus b into a minus b is nothing but a square minus this value is b square. So this is 1 by a square minus square and root if I cancel, this will be 1 by a square by a square. So if I take a square common, this will be 1 minus 1 plus a square. Again if I cancel these two, the answer is equal to 1. Therefore we got alpha beta value as alpha into beta value as 1. So we got alpha beta as 1 and alpha plus beta value as minus 2 by a. So here if I use this one, so this will become f of z value will become, so f of z is equal to 1 by ai times of this is z square minus, in place of minus 2 by a I am writing alpha plus beta into z, and in place of 1 I am writing alpha plus beta. Clear? So f of z value is equal to 1 by ai times of this is z square minus z alpha minus z beta plus alpha beta. Clear? So our f of z value is equal to 1 by ai times of, if I take z common, this will be z minus alpha. If I take minus beta common, this will be z minus beta. Clear? And therefore f of z value is equal to 1 by ai into, see here, if I if I take beta common, this will be z minus alpha. If I take z minus alpha common, this will be z minus beta. So this is our function. So with this function we have to find the residue at the interior pole alpha, so the residue f of z value is nothing but clearly f of z value is equal to 1 by, so this is ai into z minus alpha into z minus beta. This is ai into this value is z minus alpha into z minus beta. Now I am going to find out the residue value. So the residue value of f of z, see here, the residue of f of z at point z is equal to alpha is nothing but, so alpha value is also ready here as this one. At alpha is equal to, this will be limit z tends to alpha, this is z minus alpha into this is f of z. So if I substitute the same thing here, this will be, limit z tends to alpha, this is z minus alpha into f of z. What is f of z here? This is 1 by ai times of z minus alpha into this is z minus beta. If I substitute this, cancel this one and substitute alpha in place of z, so residue of f of z at point z is equal to alpha is equal to 1 by ai times of this is alpha minus beta. So what is alpha and what is beta? So this is alpha and this is beta. Therefore this value is equal to 1 by ai times of alpha value is nothing but, see here, this is minus 1 by a plus root over 1 minus, this is minus 1 by a. So this is minus, alpha value is minus 1 by a plus root over 1 minus a square by a minus, so what is beta value? Minus 1 by a minus root over 1 minus a square by a. Clear? And see, so this is ai into this is minus 1 by a plus root over 1 minus a square by a, and this is minus of minus plus 1 by a plus root over 1 minus a square by a. So if I cancel this one, so this will become ai times of 2 root of 1 minus a square by a. Again, if I cancel this one, so this is going to become 2I times of root over 1 minus a square. So this is nothing but residue of f of z at point z is equal to alpha. At point z is equal to alpha. Now we got the residue value at the interior pole z is equal to alpha. And now see here, again we have to apply Cauchy's residue theorem according to the residue theorem. So residue theorem states that according to our residue theorem, so we have integral f of z dz is nothing but 2 pi I into sum of the residues, sum of the residues at interior poles. So this one will be integral. So this is integral f of z. So what is f of z here? F of z value is nothing but half times of. So this is integral 0 to 2 pi. This is half times of d theta by 1 plus a into cos theta, which is equal to, this value is 2 pi times of, this is 1 by, the residue value here interior pole is root over 1 minus a square. So if I cancel these two, and what remains here, so this value is again equals to integral 0 to pi d theta by 1 plus a cos theta is equal to, this value is pi by root over 1 minus a square. So this is how we have to solve. So this is so important, and let me explain you once again. See here, the first of all, the question asked is this one, 0 to pi d theta by 1 plus a cos theta, and it can be written as, so this is 0 to 180 degrees, so it can be written as half times of 0 to 360 degrees. So z is equal to e power I theta. For 360 degrees, the reason why I have taken is, so it is the region with center 0 and radius 1 as a circle. For circle, the angle will be 360 degrees, and therefore I have taken 360 degrees angle. Z is equal to e power I theta. Z is equal to cos theta plus I sin theta, and modulus I have taken mod z is equal to 1. And again z is equal to e power I theta. I have write down both sides, and I got d theta value as this one. So in order to keep d theta value here, I have solved this, and again for cos theta. Cos theta is equal to e power I theta plus e power minus I theta by 2, and therefore cos theta value is this. So after getting all these values, I have to substitute in the given integral. So what is the integral here given? So this is the integral given, that is half times of d theta by 1 plus cos theta. Instead of this, I have taken this one, and after solving and after substituting d theta value and cos theta value, and again cancelling the similar terms in the numerator and denominator, I got this one, that is integral f of z into dz. So f of z value is this one. So if I equate the denominator to 0, I am getting the poles. So here I applied this formula, and they are the two poles here. Let alpha and beta are the two poles. Therefore, the pole alpha and beta is ready here. So we have to check whether the poles are inside or outside or within the circle. So here if you observe this one, so this is minus 1 plus some value here. So this will be less than 1, and see here alpha value is less than 1, and this is minus 1 and minus some other function. So beta value is greater than, so beta greater than 1 and alpha less than 1. So beta value lies outside the circle and alpha within the circle, and therefore so we have to find the residue for the interior pole. For finding the residue, here is the f of z. I am modifying this one. This is z square. If I take a common, so this is of this kind. So alpha plus beta is minus 2 by a. In place of minus 2 by a, I wrote alpha plus beta in place of 1 alpha beta, and I got the function like this. And after getting the function ready here, so I have to find the residue for the interior pole z is equal to alpha. So this is the formula, and after cancelling z minus alpha and substituting z is equal to alpha, this means alpha minus beta. So this is alpha minus beta, and after cancelling this is the value, and I got the residue value for the interior pole z is equal to alpha. Now I have to apply residue theorem, that is 2 pi I into residue value at the interior poles is nothing but this one, and this is how we have to solve. Both the integrals are same, and therefore we got the value as this. Thank you so much for watching, and this is how we have to solve. Please go through this video for one more time. If you don't understand, please practice. Definitely you can score more, and you will get a good score. Thank you so much. Share it with your friends, and look at the playlist. So many videos are uploaded for your preparation. Please avail those. Thank you so much.